All right. So first, thanks for coming. Today's presentation will be about preparing a monolith for scale. So the title is a bit different than the one that you've seen before. Introduction. So we will talk about isolation of business logic, extraction of common libraries, extraction of domains, entire domains, and introduction to gRPC, which is not Ruby, but we use it. So you had a quick presentation about our product. Hivebrite is a complex product in terms of features. We have a lot of them, from donation to internal messaging to forums to live feed to memberships, you name it. Having so many features in a single boilerplate could be hard to maintain. You have huge dependencies across your models. Test can be complicated also, but we will talk about it later. And yeah, not forget that everything is customizable. So if you're like an education customer, if you're a corporate customer, you will have the same feature, but maybe with different needs. Maybe you will configure the fees, for example, on Stripe, which is a payment that we manage for the payment. Maybe it will be different on like the customer A and the customer B, for example. So a bit of context about the stack. We use Ruby, we use Rails, which is one of the biggest part of our code base. We're using Rails for like 10 years now, so we are pretty much into it. But we are not using Rails only. We are using also Golang for some microservices when we need some performances. React TypeScript for the front end and some databases, and obviously Sidekick, this kind of things, but we didn't put everything in a single slide. You can see the stack on Stackshare. There is everything, which is kind of up to date, maybe not. Some numbers. So we have more than 3,000 tables in the database. 400 controllers, and 1.5 million line of code. So this includes Ruby, JavaScript, everything in the monolith. Because yeah, we have the front end, which is still part of the monolith, and we plan to move it outside to have like a monolith running like an API and having the front end, which is deployed outside. Another subject. Another talk, maybe. Yeah, I've seen like people like, no, don't do that, don't do that. So scaling a monolith requires good foundation. This picture has been taken this afternoon on our rooftop. So this is the view that we have from the rooftop. And I was like, okay, it's a good introduction because it's like, you know this monument. There is pretty good foundation, and they are doing things on the top, so it's working kind of well. Organization and communication across team is key. When you have like multiple people, multiple teams, squads, tribes, so many functionality area to cover from the front end to the back office to the APIs. You need to be coordinate across teams. Responsibility should be isolated. So we don't want to have like everything everywhere. It's hard to test. It's like buggy. It can be buggy. It can be hard to maintain. And when you have like, again, a lot of people, it's difficult. Component should be easy to reuse when needed. So like we can comment, for example, on the forum, but we can also comment on an event, we can comment on a donation, we can comment everywhere. We have some custom attributes. So yeah, being able to reuse some components across the application is also something which is very important for us. And test must be robust and remain fast. Even if there is some parallelization, it is possible, that we are doing, obviously, test should be fast. And yeah, also and above all, a great team to maintain everything, and a lot of experimentation, so failure and successes. Most of successes. Yeah. So the first one is about extracting command libraries. So I'm sure everyone here is aware about gems. It's pretty common in Ruby ecosystem. This is something that we've done, that we have actually. So we've decided to extract command behavior inside our monolith. So a few years ago, we were like, okay, the monolith is big. We would like maybe to experiment something, having maybe some application running in the cluster, maybe other REST application, trying something. But extracting everything from a big monolith in a single try could be risky. So what we've done is first extracting all the command behavior. So for example, we have a gem for dealing with Elasticsearch, which is the search engine that we use. We have a gem for Cloudflare for the caching strategy. And we have, so all those gems are stored in the monolith. So it's a monorepo of gems. It's easy to maintain. We are not applying some semantic versioning on it. We should. So it's why it's like 1.0.0. It's faster to update the gem here and just to publish it. But we have a gem, also this is the first one, which is Hivebrite tools, which is having some tracing modules, logging modules, everything running on top of Datadog, for example. So it's completely agnostic. If tomorrow we change our provider to something different than Datadog, we won't have to change everything in our code, just updating the implementation behind the tracer in our code.
Hello, everyone. So second strategy. It's pretty common knowledge in Rails. As your app starts to grow, as you begin to have your first successes, like you begin to add more and more features, and obviously like your controllers and your models tend to grow, it kind of, and quickly can become a mess. A lot of if-elses, you have callback hell with your validation and stuff like this. So a pretty common thing to do is to then use microservices. Services, not micro. That's for later. But yeah, we use a special kind of services. We follow the railway-oriented programming pattern, and we use a super cool gem that provides this free of charge, which is the dry monad. So yeah, to give you an example, it's used for basically chaining your business logic and focusing mainly on the happy path, which is the green line here, the green rail, right? Without worrying too much about the errors. You get this almost free of charge, where at each step, if something bad happens, like for example, something bad happened, like at the validation, you don't have the validation phase, you go on the error rail and you exit you exit right away from your business logic. So that way, it's easy to compose. Like you can reorder things like as Legos, and there are like a lot of advantages to this. So a couple ones. So it's easy to isolate the logic. You keep your model and controllers with as little as information as you need. It facilitates the testing because you can test things in isolation with your monad classes. What else? Fast testing, as I said. It's very interesting because it provides like a functional approach where you have like data in, data out. So it's very interesting. Even we noticed this. It's really interesting for junior developers because sometimes they have a difficult time to grok how to organize OO, oriented object classes and stuff, especially at the beginning of a feature where you're kind of messing around, trying to find which goes where. Having this functional approach makes it super easy to extract things, reorder things, and it's play really nice with the evolution of the feature and agility of the development. And so obviously it makes long-term maintenance and refactoring easier than with bad O, basically. Third strategy. So we've talked about like gems a little bit at the beginning, but we also use engines. So as you may already be using, there are like a lot of well-known engines out there. Like Sidekick is a known one. Device also. So it's a cool way to start splitting your monolith in isolated chunks, isolated domains, where you can have like clear boundaries to avoid coupling between your different features and avoid spaghetti code basically. Another cool also feature is that you can have like independent testing, where you can run like in isolation the tests of one engine in alone. So it's faster locally when you develop, because you can run like all the tests related to this engine in isolation, as well as on the CI, where you can like have optimization where if you didn't touch the code of an engine, you don't need to run it, for example, or things like this. And also last thing is interesting if you have like a long-term vision of extracting some business domain inside of a microservice. So it's an interesting first step where you first isolate things at the code level inside your monolith, and then it's almost ready to extract as a microservice. So yeah, pretty easy to use. Also, interesting thing is that with microservice potentially like you have like several repos to manage. With engines, you have a first step towards isolation, but still you're still in this monorepo kind of place. So it's easier to manage in the day-to-day. On top of engines, to even more enforce the isolation, we use DTOs. So it's kind of it's not that well used in Hivebrite, in the Rails ecosystem, but you find this a lot like in Java or C#. So basically, it's basically a struct, an enhanced struct, where you define your fields with some kind of typing that provides like a validation. So it's very interesting to go a step further with the isolation and have like isolation at the data level, especially in Rails, where you can tend to move around like active record objects, and it's so easy then to just call like an association or whatever, and you're like in the event feature, for example, or engine, and you call something that has nothing to do with it, like the membership stuff, for example. So with this, you enforce like a clear separation of concerns, and as well like a clear contract boundary. The only downside is that it can be kind of verbose, and it doesn't feel super Ruby-ish, I guess. But yeah, it has some interesting potential. And back to you.
This is the last part. So introduction to gRPC. So again, we have like a lot of services, Golang services. We have synchronous communication, asynchronous communication. Having the monolith be able to communicate with other services in the cluster was key. And those other services are in Go. Go is from Golang. gRPC is from Golang. It's from Google, I mean. So, I mean, we were like, okay, we don't want to rely on HTTP. I mean, gRPC is on top of HTTP too, but it's binary, which is like, which is transferring between services. In HTTP, it's text, basically. So what it looks like. Basically, we have the web app. So the web app is the Rails monolith, which is running a Puma server, so an application server. And we have also a variant of this monolith. So it's the same repository, but through environment variable, we are able to start Puma as an application server or Graph. Does someone know about Graph here? Or no? Okay. So Graph basically is a gem which is able to run some gRPC server. So you have the client and the server in this ecosystem. So basically, Graph provides us a way to have the monolith running a gRPC server and being able to respond to services like the service A, for example. It's, for example, it could be a Rails application, it could be a Go application. If you need to communicate with someone inside the cluster, it would be through gRPC first. What we use for communication between services, in addition on top of gRPC, it's protocol buffer. So it's a bit outside of the Ruby, Paris.rb conference, but this is something that we do and which is like kind of linked also to the DTO in a way. So it's an approach to like normalize your contracts. So instead of like sending everything, so sometimes it's first name, sometimes it's the first underscore name, sometimes it's you name it. We use protocol buffer to manage this kind of contract. Okay. So basically, it allows us to send and serialize some structured data. Everything is stored in a central repository, which is called the proto repo. So here we have on the right the definition of protocol buffer. So it's like a contract. So you can have like the service, you can have some method, RPC methods, and you have like the tenant policy requests, so things that come in, and tenant policy response, things that come out. You have some messages. So messages basically are kind of the DTO. So actually our DTO are stored in the monolith. But maybe one day we will maybe rely on protocol buffer to generate from this kind of structure our DTO in Ruby, in Go, in any languages, because you can generate a lot of code with protocol buffer, which is super nice. So this code here will basically package Ruby gem, a Golang package. So everything has been industrialized to do like kind of nothing. So you just have to fill your contract, to push it, and the CI will be responsible to generate the code. So the Ruby code, the servers, the clients, in Go also, if you precise on the top that you want a Go package, and you will push this code to a new repository, which are accessible by an automation user, which is the only one who can have access to those repositories, to edit those kind of repository. Everything is generated. No one can touch it, otherwise it would be like erased at the next submission. Yeah, I think we are kind of done. I think it was maybe a bit quick. No? No? Okay, well. Is there any question? Yeah, first one.
So you talked about the way you could have the Rails app with two ways, like with a configuration, you can have it as a web app or a gRPC server. Do you mean that you have several instances of the Rails app on your infrastructure to have one acting as a web app and one acting as a gRPC server?
So since we're running on top of Kubernetes, we have like many deployments, basically. So we have one deployment for the REST API, for example, which is running the Puma server. From this API, this service is like replicated like as many times as we need to, or like auto-scaling, these kind of things. And we have also another deployment for the gRPC API. Yeah.
I have one quick question about the Hivebrite tool gem. Like
Yeah.
you said, you have this shared gem. And how do you ensure that it is upgraded in your monolith when any other project change it? Because
Um,
we have the same thing. Like we
Yeah.
have a shared gem on all our projects,
Yeah.
and we had this issue that like let's say a project A updated, but project B and C lag
Yeah,
behind. And
that's
if
a
it's project C that is updated once a year, like it
Yeah.
has the update once a year.
That's a good question because we have the same issues. So what we've done for this use case, we have this one basically. We recently introduced Renovate. I don't know if some of you guys are aware about this project. So basically, it's a dependabot with testosterone. So you can program things, you can make it very strong, and Renovate is responsible to check for updates in our Docker file, for example. If the Ruby version, there is a new one, it will build automatically all the images, open the peers on the different repositories, and you just have to merge it. Test also could be done, must be done. But basically, this is how we deal with these kind of things. Actually, the Hive tool Ruby is only used by two applications, the monolith and our payment gateway, which is in Rails. But maybe in a few months, years, it will be used by other services that could be the engines that are right now stored in the monolith, but that could be maybe one day stored in like other application for performances tuning, for example.
Okay. Yeah, that's interesting because eventually we have the same solution for also. So
Yeah?
we
Yeah?
like we have the same solution. Like we have a custom dependabot. Maybe I talked about it some
Custom dependabot, what do you mean, like homemade?
Yeah, I use dependabot code, but
Yeah.
instead of having it hosting on
Yeah.
GitHub, I made my own runner in Jenkins, and like every time we run it because we use dependabot only for security CVE issues. So every time we run it, it will always update this gem, and if you update it from another project and you just run this pipeline, it will update it in all projects. So I think there is only one kind of solution for this.
Yeah, I think having like tooling in place, good tooling is kind of the only solution. Otherwise, maintaining like this kind of situation manually.
Then you
like,
come 6 months later and you upgrade it and you have like 10 versions different. And you have some,
major versions.
Yeah, so it's a kind of issue.
Thank you for the presentation. And I have a question. So you showed us that you use the DTOs in your services. Did you consider type signatures like Sorbet or other tools like this?
Take it? Okay, take it.
So you're lucky because next to you I have Luc, who had done the POC. So we tried it, and at the time it felt too verbose, more than what we have here, and not really that integrated. But that's something we want to try again. Luc is very show.
He's the guy.
So yeah, talk to him just after if you want to have like more information.
They use the survey a lot as a company, so maybe you can get some feedback from them.
Okay, awesome.
I was going to ask, is there someone from Congo here? Because we need to go there. Like 6 months ago, they made a meetup and they were explaining how they were using sorbet. And the guy from Congo had to make a Rex. He will be able to make one soon. Like how it went with the adoption.
Any other questions? Just in time.
Thanks a lot for your presentation. I just have one question. You never talked about your database. Have you shared your database? Like you told us that you have 300 tables, nice score. But my question is, have you shared responsibilities between your engines? And the second question is, how your engines communicate? I understood thanks to the DTO, but can they request the database? Or are you maybe few databases that can communicate with read permission?
Question. So for the engines, they use the same database as the monolith. The isolation is enforced within the code, and we try. Yeah, that way we don't like call shared data between engines. although, yeah, we have like some gems that are shared between the engines and the monolith, and those things are, yeah, they access the same database table through those gems. As for the microservices, they have their own databases.
Thank you for the presentation. I have a question about the Rise engine. Can you tell us a bit more about the journey to move from like a monolith with no engine and to introduce the engine? Did you introduce them like step by step, one engine after the other, or did you ask all the developers to move their code into engines? How do you decide if, do you have like one engine equals one squad, or one engine is just one domain? Do you have squad that manage several engines? Like on an organization point of view, how does it work?
Okay, a lot of questions. Interesting. So, yeah, it's a progressive endeavor. We don't do like the monolith is still big. That's something we do progressively. We don't do it for everything because we have potentially like part of the application that are maybe old, but we don't touch that often, so we keep them as it is. Usually, we tend to introduce it when we do a big refactoring or enhancement of a particular feature or particular domain, right? And again, next to you is Luc, the guy, the CTO. No, if you want to have more information about the day-to-day stuff, but usually, yeah, the hard part is to actually decouple things, right? So yeah, finding like which is which, what stays in the engine, what should be outside of it. So yeah, defining a clear boundary, that's the main job. Once you have this, it's almost smooth sales.
Does your changes affect the performance of in your work, and does it improve it, and how?
Yes, we'll take it like this. You mean like moving from the monolith to engine, for example? I mean, like application performances, actually no. I mean, it's using the same database, so if the queries are bad in the engine, in the monolith, it could be the same. Impacting like the way we work, yeah, because as Samy said, it could be a bit verbose sometimes, so it could be a bit complicated to go into the code, to understand the code. This is why we are changing things. Nothing is like stamp in the marble. Everything could change. We are trying to think about what we've done in the past, what we could done right now to speed up team productivity, testing, and resiliency of our application. So performances, I mean, no. In the way we work, can be when we start the engine. Once it's on the road, it's kinda okay to add some new features, these kind of things. But starting an engine requires some time, and so yeah, it's obviously more time consuming than doing it in the monolith. But yeah, extracting is something that we want to do. No more questions? All right, so beers.